Hi, everybody. I'm Chetna. Welcome to this webinar. This webinar is going to introduce you to some really good concepts in building information modeling and parametric designing. First of all, let me give you a brief introduction of myself. Who am I? What do I do? So I graduated from the Department of Architecture, GNDU, in 2007. There is a typo on my screen. In 2007, I have worked as lead architect for 5 years in Amritsar itself. Then I moved to Canada. I studied BIM and project management from Ryerson University. I've been working as a BIM manager for the last 7 years in a very large corporation and then a medium-sized corporation. I've managed BIM for projects way over 55 million. Some of them were complex transit projects, some of them were hospitality projects, some of them were high-rise residential. So there has been a lot of projects that I worked on, both as a designer and as a BIM manager. Last year, I founded BIMwise. BIMwise is a BIM consulting company. We do custom trainings for architects, engineers, large contractors. We also do consulting and BIM onboarding for them. We have another BIM coordinator on our team, Komal. Some of you might know Komal because she is an alumnus from GNDU itself. She joined us last year in October. She is a very integral part of our team. She works she helps me with trainings. She helps me with creating content. A big part of today's presentation has been prepared by her. Komal, do you want to introduce yourself quickly?
Yeah, sure. Hey everyone, good morning to all teachers and students. My name is Komal Sharma and I graduated from university like Chetna, GNDU in 2018. And I'm in my second year of post-graduation, which is construction project management, and working with BIMwise like for 1 year. And yeah, I hope you enjoy this session, and thank you.
Okay. So we've been talking a lot about ourselves, but I want to know more about you guys. So tell me more about you. Are you a student? Are you a teacher? If you're a student, what year do you belong to? So there's a quick poll on your screens right now. You can click on either of the options. So we have about 18 students, 1 teacher, 1 student from first year, 8 from fourth year, and 10 from final year. I promise this webinar, especially for people who are in final year, people who are planning to do their post-grad or who are planning to work as in the field of BIM. I promise this webinar, this session would be really, really helpful for you guys. Let's move forward and let's talk about what is CAD. So for me, I mean, CAD is computer-aided designing or computer-aided drafting. But what I look at CAD is as a digital drawing board. So I don't know how many of you, do you guys still use the big drafting boards and the drafters, and you do go to university with those big cases for sheets or not? But what I feel now, ever since I've started using BIM, that basically CAD is my drafting board converted into an automated process or in a technology platform. We have, and I'm not belittling a CAD because CAD has brought us where we are today. It's an amazing tool. It has made a lot of things easy. for a lot of us. But what is good about CAD is that we can do anything in CAD, like anything depending on a simple floor plan to a complex part of a machine, and let's say even a drawing or anything that you want to draw from with your hands, you can use a CAD software to use to convert that into a computer aided a computer aided drawing. So, but we are here to talk about BIM. So I want to know, what do you think BIM is, or building information modeling is? So is it a design software, or is it a process? So there is going to be a poll on your screens. Let's see, what do you think BIM is? Okay, nice. Let's see. So about 4 out of 21 think it's a software. 15 out of 21 think it's a process. Okay, let's move on. So BIM is a process. It's a process in a life cycle of a project, where from one stage of a project, let's say from programming to conceptual design to detailed design, all the way to documentation, fabrication, construction, there is an intelligent modeling happening. There is a modeling in which each stage requires some information, and that's why it's building, information, and modeling. And now here I would, if we talk about grammars, grade 6 grammar, take building not as a noun, but as a verb. So we are building information into the model. So when at every stage when we require, we build some or other kind of information. Just for example, if you create a room, you are the dimensions, the square footage, the material, the placement of sockets, everything that we put into that particular drawing or model is a piece of information, or something that we call in these days is data. So it's basically including data in your in the stage of drawing that you are, a stage of design that you are. Now, I would like to think as BIM as a seamless transfer of information at different aspects. So I would simplify this in my own way, and I would say it's more, say, let's start from, we are architects, so let's start from design and development. So when we gather requirements from our clients, or let's say in a college assignment, in a university assignment, our teachers give us requirements. So collecting the requirements, then doing the analysis on it. Now, analysis is at different parts. There is, I would say, let's say green building analysis, or sustainability analysis, or structural analysis, or energy analysis, or mechanical analysis. So different parts, or even design analysis. So analysis is next part of our project life cycle. Then the next part is construction and planning. So let's say this is a real world project that we are talking about. So when we talk about construction and planning, and people who would, from their final year, would want to move to construction management or project management, they would see that construction planning and logistic planning is a very important part in large scale projects. And then let's talk about fabrication or operations. And operations is basically when your project is ready, it is handed over to the client, and client gives that building, that asset to some other party to manage, to maintain, That is the operation and maintenance part of it. And at each stage of my project life cycle, I want some information. Say, for example, when I designed, let's say, an office building, um, how many rooms do we need? How many floors do we need? What is the floor to floor height that we need? What is the angle? What's my energy requirement for the building? So all this information, eventually at each stage, we are trying to input in the project. And when we build information at each stage, and we use the information from previous stage or a stage that's going to come, that's where my building information comes. And we use different softwares for this. There is not one single software that can do everything. I will just quickly give you an overview that how different softwares are used at different stages at in a project life cycle. Let's say in design stage, you might have heard about ArchiCAD or Vectorworks or Revit, but there are also other softwares in the market that do design and development. At the analysis stage, we have Green Building, and we have Navisworks. Navisworks is for clash detection. Tekla Structures is for structural analysis. Then we, at the construction and at construction planning and logistic, there is Synchro, there is Assemble Systems, there is Archibus. These are the ones where if people who are doing project management right now, they would know that how Gantt charts are made, or how construction planning is done in these softwares. And it comes from the information that was in the 3D model, the model that we created at design stage, and the model that was analyzed at the analysis stage. Once the construction is planned, then we go to the fabrication part of it. And then there are different softwares that use fabrication softwares to do. Let's say, for example, there are steel beams that have to be used in a structure, or there are some hardware that is going to be used in a building. So all that is designed in a different software. And when everything is done and the building is complete, we hand it over to the client, and the client has to maintain it and operate it. Then they use different kind of software to report if there are any problems in the building. Let's say, for example, HVAC in the building. If I've created my design properly, I have my structural design, my mechanical design, my electrical design, everything is in proper place. Whenever there is a maintenance issue or an operation issue, my 3D model will give me exact information where to find that problem from. So right now, this is the whole life cycle of a project, in which at different stages we are using different softwares. But what is key in here is that my information flow from one part to the other is very seamless, and we are able to extract the information from the model that we have generated the way we want to, or we can input the information the way we want to. Now, I have discussed various stages. Now I will also put a little bit light on how each stage, and why do we need BIM, and how at each stage BIM will be useful to us. So let's say at design and planning stage, what happens at design and planning stage is when you're gathering requirements from a client, when we are discussing different options for a client, when we are discussing different strategies with the client, when we are able to show a 3D model, and when we click on, let's say, one part of our virtual model, and we can show the client that this is the material we are going to use, and this is this is how much material that we are going to use, or these are the options that I'm looking at. It gives a better service to your client. Plus, these softwares, because they are not plain 2D drawings, we are able to visualize these designs in a much better way. We are able to produce the drawings in a much better way, which moves to the next stage, that when I am able to really see a 3D model, I don't have to make an extra effort in creating a new 3D model. So I've had, let's say I had 2D drawings, and I really cannot imagine if there were two pipes that were hitting each other or were just overlapping each other. When I'm able to see them in a 3D view, then I'm able to analyze and schedule and sequence my design in a much better way. And similarly, in my construction and my fabrication, when my contractor or the fabricator has the 3D model in their hands, they are able to see where their fabricated part is located, and if they need to go back and forth for any kind of collaboration, for coordination, when they can see in a model or in the software that this is where this part belongs, it becomes a very easy collaboration and communication tool. What it also does is it just before we start construction, we can always perform through these some of the softwares like Navisworks or CATIA. What we do is just before our construction is done, we run a clash detection. When we run a clash detection, we would know where my beam is hitting my water pipe, or where my mechanical duct is hitting a column, or where my mechanical duct and electrical duct are hitting. So all these things, because everything is into a 3D model and we can really go inside and we can go and see where everything is, it becomes a very, very productive and a very cost efficient way to work. And similarly, when I have a completed model and I hand it over to the client, the team that operates the building, the team that maintains the building, they can, and there is information attached to it. Say, for example, the sockets in the building or the furniture in the building, they have information, they have vendor information attached to it, they have material information, or they have cost information attached to it, or there is some kind of information that is attached to the 3D model. They're easily able to locate the problem and fix it or generate tickets. So it's a very wholesome process, and not one individual can be master at each stage. But what we do is that if I can master one stage, at least at one stage, I'm able to do better service or a better design process. Let's talk about parametric designing. So what is parametric designing? Parametric designing is an approach where a designer can set up different parameters or different conditions to their design. Say, let me give you an example of a small residential building. So what happens is, let's say in a residential building, I have some front setback and side setback, and then there is some fire rating that I have to meet, or there are, or this is a building for, let's say, for senior people, or building needs to be for accessible people, for accessibility purposes. When we put all these parameters inside the design, my computer program generates the options for me. So let's say in a small house, I say this is a 30 feet by 90 feet plot. I have to set up, I have to give a front setback of, let's say, 10 feet and a rear setback of 5 feet. And then side setbacks have to be 5 feet each. So I have a square block. Now I want 10, I want 3 bedrooms in it, and I want 1 kitchen in it, and this has to be 3 floors. So what happens is that by setting up these conditions and setting up these options, my program generates options for me, and then I can mix and match those options, or I can optimize those options according to my client's requirements. So basically what parametric design does is it takes up your parameters and it gives you the options. One example that I will give you in parametric designing is Dynamo in Revit. So if I will quickly show you, this is a small Dynamo project that we did. Some of you might also be doing this through Grasshopper, and it's very similar if anybody is aware how Grasshopper works or how Dynamo works. So it's a visual programming plugin within Revit. We set up different parameters in there, and then we can adjust the height. Just see this example. In this example, what happens is this is a twisted building in which each floor is at a different angle, and each floor has a different height, and we can adjust the height or the rotation of the angle and create the shape, or we can increase or decrease the number of levels, and we can create a shape. And once our conceptual is done, we can detail each floor accordingly. So this is one example of parametric designing, but parametric designing has a wide variety, and a lot of these BIM enabled softwares, they do give you an option for parametric designing. And if you would look at all the BIM authoring tools that are available in the market, there is ArchiCAD, there is Revit, there is Ecosim by Bentley, there is Vectorworks by Nemschek. I'm pretty sure a lot of you must be using SketchUp. So SketchUp is also enhancing its functionalities. It's adding more BIM authoring tools into its program. Then for construction planning, it's CATIA or Allplan. For fabrication, there is SolidWorks, there is Rhino, there's Tekla. So all these, depending on what we are doing in a project or how we are approaching the design, we will use one or the other. And sometimes it's also that, ArchiCAD is a cheaper software than Revit, so maybe I prefer that. Or maybe Revit gives me a free trial version for students, so maybe I'll use that. So it all depends. More or less, the basics of each one of this is same, and that is that you create a 3D model, and when you create that 3D model, you're building some kind of information in that. And the purpose of that information is that at some stage of the project, I can use that information, I can leverage that information, and I can do what is required at that stage. Now, we have talked about so many softwares, and honestly, it's not very easy for everybody to learn a lot of softwares. Like even working in BIM for last 7 years now, I don't know a lot of them, or I know a few of them, I can work in few of them. But what happens is, because I know the concept of BIM, I can navigate through these. I can see that, okay, this is, let's say this is Vectorworks. How does Vectorworks work? Okay, I can open the drawing, I can see, okay, because it is a BIM-enabled software, there has to be an information part attached to it. There has to be a 3D modeling part attached to it. And because it's for architects or for designers, there have to be functionalities like walls or floors or ceiling, all the things that we use. We will eventually, and it all depends on, some of them are really good at one function, some of them are really good at other function. But as a BIM advisor for so many years, what I have found is that Revit is one of the most popular softwares out there. It has many reasons. One, because it comes from the same parent company, Autodesk. So people who are using AutoCAD for a long period of time, it's very easy to switch to Revit because there are similar usabilities, there are similar terms used, and plus Autodesk is good at marketing their softwares. So, and it has a wide variety of softwares. If you have friends in let's say mechanical engineering or electrical engineering, ask them that what BIM software they are using, and they will say they're using Revit. Or if you know somebody from fabrication, a product or a part designing, ask them what they are using. The most answer you'll get is SolidWorks, because SolidWorks does a really good job with designing small parts of a machine or designing small parts of hardware. So there is a reason why these softwares are really, really popular. But let's focus on Revit for now. And I will quickly explain that what Revit is and how is it useful for architects. What do they use it for? And here I will, I'll share a very interesting stories with you. So I remember back in 2012, when I was getting ready to, move to Canada for my new life. And, I was so excited that, okay, I'm going to do this and this and this. I started researching and I started seeing that there a lot of jobs were asking for Revit. So I decided, I said, okay, let me learn this software. Back then, YouTube was not so rich in any kind of tutorials. And I started looking at a few options where I can learn Revit. So I did not find anything in Amritsar. I found one Autodesk authorized training center, and I learned Revit from them in about, I think it took me a month to learn. And then I did just one project. I was working in Amritsar in a company, and just on my own time, I started working on an interiors project. And back then, I had so much time on my hand that I designed the bedroom of a house, and I also designed in Revit. I did what do you call it? The drapes. I designed the drapes in Revit. And it was so crazy, like the model became so heavy. Back then, Revit was not very user-friendly. It wasn't very, I mean, the file sizes were at one point of time, the computers weren't so great as they are today. So eventually, once I was done with the last part of my design, the model broke down. And then I realized that there is something called level of design in Revit. So then I decided that, okay, no, this is what I am going to do in Revit. And this is that I would leave for a hand sketch, or this is what I would leave for a visualizer, or somebody who would, do a more specific rendering in the software. But as we progressed, Revit has improved a lot, and now we can do almost everything in Revit, anything design related. So we can create conceptual designs, we can do visualizations, and like when we are creating our 2D floor plans or views, we can see our 3D views side by side. I would highly encourage you that if you really want to see how Revit works, we have some YouTube tutorials on our YouTube channel, and you can see how these things work. At the end of the presentation, there will be a link to the YouTube channel that we've created, something that Komal has been working really hard and creating a really nice tutorials. Go have a look and you will find that how design and visualization work side by side in Revit. Another thing that I really like about Revit is it's very user friendly, because what happens is that it has a way where you can see two screens at a time. So you can see a floor plan and a 3D view at the same time. You can see a plan and an elevation at the same time. There is a very user-friendly user interface where it's very clearly mentioned that this is the tab for architects and this is for structures and this is for MEP. So it's like, it is, even if you try on your own, you will be able to navigate some parts of Revit on your own, even without a formal training. Of course, if you need a really detailed design and you need a really detailed insight of the program, you would need a formal training. But if you're somebody who's good with softwares, you might be able to figure it out yourself. Another amazing feature that I love about Revit, and which is actually missing in a lot of other BIM-enabled tools, it is its ability to collaborate. So it comes in a way, it comes in a format where 6 to 7 people in a team can work on the same 3D model at the same time. Different teams can collaborate. They can work at different on different aspects of the project at the same time without. I see some hands being raised. We will keep some time for the questions at the end. If you have something that really you wanna ask, I would recommend that you can type it in the chat box and I will be able to take all the questions at the end. So I was talking about the collaboration part of it. So what happens is, let's say me and Komal and 3 other people are working on a big office building. So let's say Komal wants to work on the envelope part of the building and I'm working on the interiors, and then there's somebody else who's working on the overall design. So we can all bifurcate our work, and we will be able to work on our own and then synchronize our changes in the model without disrupting anybody else. So this is one part that I really, really like about Revit, which is missing in ArchiCAD, which is also missing in Vectorworks. Rest of the softwares I haven't tried much. So if you want to try, you can see all these softwares and see, and let me know if you find something interesting. So these are some things that I have really liked about Revit. I want to specify that how Revit is a BIM authoring tool. So if you see in the visuals right now, I would say that, let's say we created a 3D model in which I want to just see a door schedule. So all the schedules are made automatically, but how are they made? We generate the information right from within the model. Each door that is inside the model, it has some properties, it has some aspects attached to it. And right now, if you see that all these schedules have let's move. Okay, so what level they are at, what type of door it is, how many doors there are. So we can really create a schedule right from inside the model without actually going and manually typing in. And then we can also export all these schedules into an Excel sheet, and just give it to the fabricator or give it to anybody who's doing another kind of coordination on the door schedules. So, and this is one schedule, but we can create room schedules, we can create hardware schedules, we can create any kind of schedule that you would want in Revit. So how is it creating that schedule? It has information attached to each model, each piece of model. So each door has some information attached to it. For example, the material, the height and the width and the thickness and and how many are there in the model. So, or even we can attach information like what company are we sourcing that door from, or what wood are we using to make that door from. So this is all that we can generate from a model because we've input really good information into the model. The next thing that I really like I said, the work sharing part of it. So what happens is that this visual will show you that how different teams can collaborate and make one model as a work shed model, where if you see there's something called work sets, so you can create different work sets and each person can take up their work set, put the elements that they are working on that work set so that they do not step on anybody else's shoes. And that's also the information part of it. So what I did was that, let's say, for example, I put all my walls on a work set called walls. So the information attached to that part of model is that it's a wall, and I'm putting that I'm putting those walls on the work set named walls, and now I can work on it. The next and very, very important part of Revit is generative design. This is a new feature that Revit 2021 has introduced. In here, this is actually hybrid of both information modeling and parametric designing. So what happens is that I am inputting information into my design, and then by setting up those parameters, I'm looking at the options that it will give me. And if you, and based on that information, it gives me options, and it gives me studies, and it gives me an optimized alternative of all the design options that I'm creating. Let's talk about Revit as a parametric designing tool. So we did talk that how information modeling is possible in Revit, how parametric designing is possible in Revit. So what happens is, like I said, Dynamo is a very, it's a plugin inside the Revit, where it is kind of a visual programming. So people who know a little bit about what coding is or what programming is, Dynamo comes easy to them, but it's not a difficult plugin to learn. It is specially designed for architects and engineers who have a non coding background. It works as simple workflows. So let's say collect all the doors that have that are 30 inches by 80 inches, and then I want to name all those doors as D1s. So it's a this example is a very simple usability of how Dynamo works. Then I create a workflow. There are nodes inside the Dynamo that can that will take up these commands and then give you the result that you want. But it also creates complex geometries. This visual here is not very clear, but what it is actually doing in here is that it is creating different lines in X, Y, and Z axis. and it is creating a complex geometry with the help of Dynamo. So what we are doing is we are setting up different parameters within Revit, and then we are giving it a command to run. And then that command actually, when we specified that my x-axis and my y-axis and my z-axis, this is how my arch needs to run. And then let's say run 10 arches like this, and then join all these arches. So this is how my complex geometry will be made in Dynamo. Another thing that we can do in Revit, which represents the parametric designing part of it, it is creation of families. So there is something called families in Revit, which is very similar to how we do blocks in CAD, but in AutoCAD, but it's a much more hybrid version of CAD. And I would say that, let's say, for example, I created, in this example, a dining table with 4 chairs. Now, what I do is I created a radius of 2 feet 6 inches, and then it created a circle. Now, inside my family, what I can do is I can increase and decrease the radius. And when it increases the radius, the number of chairs increases. When it decreases in radius, the number of chairs decrease. So this is how my parameters work. So I have given some parameters, I've given some conditions that when the size of my dining table, the radius of my dining table is 2 feet 6 inches, attach 6 chairs to it. When it is 2 feet, attach 4 chairs to it. So these are the conditions, or these are the parameters that I set up within the family, and then that becomes my parametric designing tool. I have done a lot of speaking. I need a little bit of break. So I'm going to give you guys a poll, and just tell me what part of Revit excites you more. Is it BIM? Is it parametric designing? Or is it both? And then there'll be another poll that will talk about, do you think BIM and PD, or parametric designing, are mutually exclusive? So the poll is on your screens now. If you've understood what I've said, these might be fairly simple questions to answer. So Komal, what part of Revit excites you more? Is it BIM part, or is it the parametric designing part?
That's definitely the BIM part, because I work more on the BIM part rather than the parametric part. Parametric is a bit complex, I feel so.
Okay, people who like math, parametric designing is, I feel parametric designing is where math and art meet. So if I know how to use numbers to do the designing, parametric designing is the most, it's very interesting. Exposure towards Dynamo and Grasshopper, and then you would love it.
Yeah.
So about 76% people say that their parametric designing and BIM both excite them. Almost 5 people are like you, Komal. They don't want to see. There are typical architects, man. They don't want to go in the math part of design. They just want to stick to the modeling part of design.
Yeah, everybody is not good at maths like me.
you guys have cracked that exam. We never gave that exam. What is it called? NEET?
No, I gave the NATA exam.
Yeah. So does NATA have math?
No.
Okay.
Yeah.
I would like to answer the second question, and which is are BIM and parametric designing mutually exclusive? They are not. If you are getting, if you are doing anything in information modeling, some part of it will use parametric designing, because what is parameters? Parameters are specifying the conditions for your design. Only when you specify conditions for your design, that is when you will input information. So just like I said, take example of a small residential project. It's a 30 feet by 90 feet plot. You have a front setback, and you have a side setback, and you have a rear setback. And then there are, let's say, 3 floors that you can go. Now, if I have set these parameters up, now if I need a design, I need to input information. So that the front setback is 10 feet, the rear setback is 5 feet, the side setbacks are 5 feet, the number of floors are 3. So you see how I have added information to it, right? So now when we add information to it, I'm obviously doing information modeling based on the information that I've provided. I am setting up the parameters, and I'm setting up the information, and that's how I'm creating my modeling. So BIM and parametric designing is not mutually exclusive, but yes, we can focus more on one aspect. So we can focus more on BIM while doing a little bit of parametric designing, or we can focus more on parametric designing and adding some part of modeling into it. Let's move to the next part, which is Revit for architecture students. So, you know, if I had known how good Revit is, and I had known that Autodesk gives out free licenses to students, I would have done my thesis in Revit. Because yeah, even back then in 2007, Revit was available and people were using it around the world, and it would have made a lot of my life easier. Anyways, there are lots of uses, lots of benefits for architecture students to use Revit. And if I start counting each one of them, half of the people will leave, because it will take me at least 5 hours to cover all of that. So I'll focus on 2 or 3 big, I would say about 4 broader uses of Revit for architecture students. And I would highly recommend that if you guys are really interested in the 3D part of it, and you guys want to learn more about BIM, grab the opportunity. Autodesk gives out free licenses to students and also to the teachers, to educators and to students. If you guys have an institutional email ID, you guys will be able to get the license. And a lot of these software companies, they do. I know even ArchiCAD does that. So just try it. First most important part that I feel, that when you're a student, you kind of have a blind side towards how things work in real life. Or, you know, I am designing something and I'm imagining, what if when I'm designing something and I can actually see how does it come up I can actually create a digital twin of what I'm thinking. And when I'm designing in 3D, I'm making a better design. Plus, it's giving me a real world, a tangibility. It is showing me how my project will come up, which makes my design better. It also, because it's creating 3D views along with 2D, it is giving me the options of creating beautiful renders and visualizations. And like I said, with the increased computing powers of computers these days, and Revit increasing its possibilities, what all we can do, you can also use plugins like V-Ray, and you can export this to the 3D views to 3D Max, and then you don't have to actually create the new model from scratch. You can actually export these models and create really good visualizations for your model, especially people who are in 4th year and final year. The expectations out of them are really high, that at this stage, when they have spent 4 or 5 years learning the design process, they can actually give out the visualizations that are, I mean, I have seen some of really good renderings and visualizations in thesis. And if somebody wants to use Revit for their thesis, I promise you your work will be reduced a lot, especially the design part of it. Of course, research part, you will still have to do it the conventional way, because that's how research is done. But at least the drawing part, the modeling part, a lot of it does it for you. Also, people who are going, and this is again for students who are in their 4th year or final year. So I know some colleges, some universities, they have their internship in 4th year, and some have their internship in final year. But Revit is a skill that anywhere if you go for internship and you say that I know Revit, your employer takes you much more seriously. And the earlier you learn it, the better it is for you. I would still recommend that do not start it in 1st year of your degree. Develop some design skills, develop some design aptitude before you move on to a digital platform. But definitely 3rd, 4th, and final year students should learn a BIM software, and Revit is highly recommended because it's highly in demand. All the bigger corporations now, they are moving towards Revit, or they're moving to some or other kind of BIM software. It also gives you option of creating a lot of design options. So Revit in itself has option that you can, within the same model, you can create 2 or 3 different options, and then study these possibilities and come up with a better design. And what better than not have to do the whole drawing all together to create a new 3D model. You can really create the design options within your model. And ultimately, you have to, after all of this, you get exposure to BIM. BIM is a very, very important skill. Today, I would say all over the world, people are being exposed. People are adopting BIM really fast. Sitting here in North American market, I can say that if you're in architecture construction industry and you do not know what BIM is, getting employed is really hard. I know I have friends in Australia, in New Zealand, in Middle East. All the bigger offices, they have adopted BIM because they have seen the usability of BIM. There are specializations, just like if after your graduation, if you're going to, let's say somebody's specializing in urban design, or somebody's specializing in interior design, or somebody's specializing in product design, or somebody's specializing in something or the other, or construction management. BIM is something that will be a very important skill. But then there are also master's programs that help you specialize in BIM itself. And everywhere, depending from, ranging from architecture to construction to engineering, this is something that the industry has actually in North America, it has gone to BIM, I would say about 70 to 75%. And even in India, I have seen that at least the bigger corporations, they have started adopting BIM and they've started working towards BIM in some or the other way. It's 2 a.m. almost in the morning. My building is doing some energy conservation, so the lights have turned off. I will have to really go out of my room to turn on the lights. Anyways, thank you so much, guys. You have questions? We still have about half an hour. We have what now? Yeah, 25 minutes we have. So the floor is open to questions. Let's see the questions that we have. So there is Tanzil Ahmad, and Tanzil Ahmad is a he or a she. So they say that, is BIM useful for interior designing? Absolutely, yes, it is. We actually at BIMWise have a specialized program just for the interior designers. So we work with a lot of interior designing companies, people that just do interior designing. They have adopted BIM. There is a very, very specialized program. We don't go through a lot of things that architects or and a structural engineer would need. We focus on what interior designers need. So yes, it is a very, very useful tool for interior designers. How can two-person work on the same file at the same time? Good question. But so what happens is, I don't know if I can explain it so efficiently without actually giving you a demonstration. But what happens is that there is the main model or the central model is on a server, and there are users who are attached to servers. So what they do is they tap into the central model, and their computer makes a local file of that model. Now you keep on working on your local file, and then you synchronize the changes in the central model. And if you attend the training, I will be able to demonstrate that in a much more efficient way in the training session. Parametric, the parametric models are too heavy in Revit, and complex geometry are very much. So how do you tackle it? So the thing is, when you make parametric models, what you do is that you do not start detailing in the same model. So when you create a parametric model, can you create, and when you are done with your parameters, you actually export that geometry as a background, and then you do the detailed designing on the linked model. That's how we do it. But this is a very, very specialized situation. If you share what you're doing right now, email me with the snapshot of what you're doing, and I might be able to help you. If someone is using ArchiCAD, do they need to switch to Revit because it's more popular among offices to get a job? Revit is very popular for sure. If you are doing ArchiCAD, I believe that you understand the basics of BIM, and you can always, take up a small program, a small training program, and it is. It's not rocket science. We architects are really smart people. We can understand. If we know the concept of BIM, we can understand any of these softwares. Again, I would say that visit my YouTube channel. We have a lot of tutorials on there. Actually, somebody was asking that how do we work at this, we work on the same file. We have a YouTube, we have a video that explains in detail how a work shared model works in Revit. And yeah, it will be, okay, what what do they say? I know how to work in Revit, but it lacks the render quality. What can be attached? Okay, so you can plug in V-Ray into Revit. What a lot of my friends do is who are into actually visualization, they export the Revit model into 3D Studio Max, and then they render in 3D Studio Max. What earlier they used to do was that they would have a floor plan and they would actually make the whole model. But what you do is if you export, Revit has a wide variety of export options. So you can export it in 3D Studio Max or Lumion. Komal, you've used Lumion, right?
Yeah, I've used that. It's
And
3D render.
Yeah,
software.
Lumen works really fine. There's Enscape that works really fine. In fact, Enscape is also very light. So you can use all these plugins inside the Revit to get a really nice 3D view, rendering view. Can we get precise drawing like AutoCAD and Revit? Which one? Oh, yes, absolutely. In Revit, you can do absolutely anything that you've done in AutoCAD. You just need to know how to do it and learn Revit from somebody who has gone through that process. Any more questions? Okay. I think I have enjoyed this session a lot. And do we have one more question in here? Okay. Do let me know if you have any more queries. Most probably, I have a list of people who've attended. I will send the registration link for the Revit intro class, and we'll fix the 20 people that are in there. If you have any questions, you can write to me at info@bimwise.com. You can follow us on Twitter, on Facebook, on LinkedIn, and on YouTube. I promise if you send me a connection request on LinkedIn, I rarely reject anybody until unless somebody is very obnoxious. I do not reject people on LinkedIn. And you can reach me or you can see what we are doing at BIMWise on our website. And it was nice being in touch with everybody after so long. And thank you very much.
Thank you everybody for attending our webinar. I hope you enjoyed that.